All right, on to section 3.1. Let's do number 1. It says compute the determinant using a cofactor expansion across the first row. And here's the determinant. So notice the difference in notation between determinant and matrix. When we write down matrices, we put them between square brackets, and determinants they almost look like absolute value bars. But another thing to remember about the difference between the two is a determinant is always a number. A matrix is a rectangular array of numbers, which is different in general. But a lot of you might have seen this technique before, but you can expand about any row or column, but they want us to expand about the first row in this case. So here's what you do. Write down the first element, and then you multiply it by the determinant that you get if you cross out everything in the first row and the first column. That'll give you this. And then you change the sign, you subtract the next element in the first row, which is -2. It's always plus, minus, plus, minus, plus, minus, at least for the first row. And now cross out everything in the first row and the second column. That'll give you these. And then we'll do a plus 4. And then for the 4, cross out everything in the first row and the third column. That'll give you this stuff right there. And you might remember the 2 by 2 determinants are easy to compute. It's always this minus this. So -2 minus 15. -6 minus 3. 15 minus 1. All right, and so you would just plug all that into a calculator. I think my computer wanted me to leave it in unsimplified form. So let me double check. That looks right. And I guess I'm supposed to plug that into a calculator, actually. You know, a calculator will actually compute the determinant of a matrix, too. If you go to matrix and then math and then determinant, you can enter, see, there's the determinant thing right there. You can enter determinant and then choose a matrix after that. But anyway, but I want you to be able to do it the hard way, too. You can't always do things with a calculator. I get a 4, though, because sometimes you actually use matrices on variables, and you might have variables in there instead of just numbers.